Welcome to online lecture series in organic chemistry, and hereby we are discussing the concentration of ore. In earlier video we have seen the concentration of ore by hydraulic classifier method or hydraulic separation method. Next method is electromagnetic separation for the concentration of ore or magnetic separation process. This method is used when either the ore particles or the gangue particles shows magnetic properties. Now in this method there is a electromagnetic separator, and this electromagnetic separator consists of a leather or brass conveyor belt. So this is the leather or brass conveyor belt moving over two rollers. These two are the rollers. Out of these two rollers, one is magnetic roller. This is the magnetic roller, and this one, it is the non-magnetic roller. The powdered ore, it is dropped over the belt at one end where the non-magnetic roller is placed. Or actually this is the powdered ore. It is charged on this leather belt very close to the non-magnetic roller. Now as soon as these two rollers are rotating, the belt should this belt rotate in this direction like this. So this powdered ore particles containing magnetic and non-magnetic particles, mixture of magnetic and non-magnetic particles, they move towards this magnetic roller. So when the ore passes over the magnetic roller at the other end, magnetic portion of the ore sticks to the belt due to the force of attraction, and it falls near the roller, whereas non-magnetic particles, they will pass little bit further away, or the non-magnetic part or particles, these will be collected in separate container. Actually these particles are not attracted towards the magnetic roller, and they will be collected over here, and magnetic particles, these are collected in another container which is close to the magnetic roller. So in this way, by using magnetic separation process, ore and gangue particles are separated from each other, but here condition is out of ore and gangue particles, one must be magnetic, otherwise this process will not be applicable. If both ore and gangue particles are magnetic, then both particles will be collected in same container, and method will not be applicable in that case. So this method, magnetic separation, it is especially applicable for the separation of hematite from the silica, hematite ore from the silica as a gangue. Actually hematite or chromite ore or hematite, these two ores are magnetic ores, and silica, it is non-magnetic. So hematite, it is separated from silica by this magnetic separation method. Then wolframite, it is also separated from cassiterite. Wolframite, it is the magnetic ore, its molecular formula is FeWO4. this is magnetic ore. It is separated from cassiterite. Cassiterite, it is non-magnetic, maybe gangue particle, suppose its formula is SnO2. Then rutile titania, TiO2, this is magnetic material. it is separated from chloropatite. Chloropatite, it is non-magnetic material. So in this way, by using magnetic classifier or electromagnetic separator, we can separate ore and gangue particles. Now next method, the froth flotation method. This method is used to remove gangue from the sulfide ores, and this method, it is based on the different wetting properties of ore and gangue particles by liquid. Ore and gangue particles, when they have a different wetting properties, then we can separate ore and gangue particles by means of froth flotation process. In this froth flotation process, there is a one tank. In this tank, actually air is passed through this one pipe. There is a water containing oil, and when air, water and oil are thoroughly mixed, there is a formation of foam or froth. So to this mixture, the impure ore is charged, especially sulfide ore containing the silica impurities. It is charged in this container. Now here, as soon as the powdered ore comes in contact with froth and water, then here the finely divided ore, when introduced in water containing small quantities of oil like pine oil or eucalyptus oil, and when the mixture is agitated or stirred violently in presence of air, the silica particles or the earthy matter wetted with the help of water and settle down at the bottom of tank, because earthy matter, it is heavier than the sulfide ore, whereas the metal sulfide particles, these are the wetted by froth, which is formed by mixing oil, water and air. And these sulfide particles, these are floating on the surface of this foam, because these particles are lighter. So these particles, ore particles, are further taken out, and hence the sulfide ore, it is separated from the silica impurities. This is the simple method. Now some different chemicals used in this method. One of the important chemical is frothing agent. Now what do you mean by frothing agent? The chemical which produces froth when air is passed through the emulsion, it is called as frothing agent. And the most common frothing agent is pine oil or eucalyptus oil. These are the frothing agent. What is the function of frothing agent? Frothing agent lower the surface tension of liquid and causes or produces bubbles to form stable froth. So this is the frothing agent. Another important chemical added at the time of froth flotation process is collecting agent. Now since the froth flotation process depends on or based on the principle of selective wetting, the collecting agent makes the metallic particles, especially the zinc sulfide particles, hydrophobic, that is water repellent. As they are water repellent, then these will be away from the water and float on the surface of froth. So this is the function of the collecting agent. Collecting agent makes the metallic particles hydrophobic, that is water repellent. Now for non-sulfide ores, oleic acid is used as a collecting agent, and for sulfide ore, potassium ethyl xanthate, it is used as a collecting agent. So this is about the collecting agent. Now next chemical added, that is the activating agent. Activating agent makes the mineral or ore get wetted easily with the help of collecting agent. So activating agent plays the role comparable to that of promoter used during the catalysis. Actually, promoter activates the catalyst. In same manner, the activating agent activates the role of the wetting agent. So it makes mineral gets wetted easily by collecting agent. And the important activating agents are lead nitrate, this is used for stibnite, that is antimony sulfide ore. Then sodium sulfide, it is used for copper ore, that is malachite. And copper sulfate, it is used as activating agent for zinc blende. So this is about the activating agent. It makes the mineral or ore gets wetted easily by means of collecting agent. So it increases the function of collecting agent. Now next is depressing agent. So depressing agent makes ore less responsive towards the collecting agent. So they have the opposite effect on the activating agent, and they are used when there are 3 or 4 kinds of metal particles, and it is necessary to employ a stage wise selective flotation, that is one by one. When we wish to separate the sulfide ores, then this depressing agent is used. So if sulfides of iron, copper, nickel have to be separated, then slacked lime is added, which depresses the iron sulfide. So this is the role of depressing agent, and depressing agent is added when there is a mixture of 2 or more sulfide ores. Then for the step by step wetting of these sulfide ores, the depressing agent is used. It depresses the separation properties of metal sulfides step by step. And the last chemical, that is the conditioner, it is added in froth flotation process. So conditioner or pH controlling agent, it is added to control the pH. So pH control, it is necessary as it is efficient for the separation of ore from the gangue particles. Especially sulfuric acid is added to lower the pH, and lime or soda is added to increase the pH of the mixture. So this is about the froth flotation process. So after concentration of ore, the ores are subjected to calcination or roasting operations to convert ore into easily reducible form. Metals are usually present as hydroxide, carbonates and sulfides. These are further converted into oxides. So next step, it is calcination. This part we will discuss in next video.